is what is energy and correlates with chapter 12.1 in your textbook. Your key concepts for this video are: how are energy, work, and power related? What are the two types of energy? And how do you calculate kinetic and potential energy? So let's look at how these three things are related first. Energy, if you were to look it up, is the ability to do work or cause change. So it's the ability to do that work. That's ability to move something using a force. So work is simply the transfer of energy. So both work and energy, their SI unit is the joule. So, relating this then to power, you could also say, instead of power being work over time, you could say it's the amount of energy transferred over time. And remember, power are measured in watts. For example, taking the stairs versus an elevator. I don't know if you ever did this when you were a kid, but my sisters would take the elevator when we were staying in hotels, and I'd try and race them on the stairs. I never won, but I would try, because elevators have more power. They do the same amount of energy transfer, covering that same distance, in less time than it takes for the stairs. So it was always an exhausting challenge, but feel free to try it and see if you can generate more power than the elevator and you can beat it up the flight of stairs. So let's talk about the two types of energy. You know this from 6th grade. We've got potential energy and kinetic energy. And then those are further broken down into different forms with mechanical, chemical, nuclear, electrical, electromagnetic, and thermal. We'll be looking at these different forms in a later video. Let's look a little bit more in depth with potential energy. Potential energy is stored energy, meaning it's not being used right now, but it can be used. It's got the potential to be used. And there are four main forms of this. You've got gravitational potential energy, like when I hold my little camel up here, if I let go, my little camel falls. She has potential energy from gravity when I hold her up here. The higher up you are, the more potential gravitational energy you have. You've also got elastic energy, like in the bow that Katniss is pulling back. The farther you pull it back, the more elastic energy. This is a form of mechanical energy. There's also chemical potential energy. This is the energy that's stored in the bonds of, say, like our food or in batteries. So it's there and ready to be used when it gets transferred into something else. And then there's nuclear energy. This is the energy that is released when the atomic nuclei are smashed together to form one or broken apart to form two different things. This we'll look at more later. We can calculate gravitational potential energy, which is the main one we'll be looking at, with this handy equation. Potential energy, PE, equals mass times gravity times distance, the height off the ground. You can simplify this as well and do potential energy equals weight, because remember, weight is simply the force of gravity on your mass, times distance. So that's how you calculate potential energy. Now, kinetic energy, on the other hand, is moving energy. Things are moving around and going all over the place. There's lots of different types of this as well. To calculate it, we have kinetic energy equals 1/2 mass times velocity squared. So there are two things that can affect your kinetic energy: your mass and how fast you're moving. Generally, how fast you're moving influences your energy far more than your mass, but they're both a factor. So if we were going to use this, here we've got kinetic energy, and we do this guy pushing the ball down the hill. Let's say the ball has a mass of 5 kilograms. So you do 1/2 times 5 kilograms, and let's say it gets a velocity of 10 meters per second. So 1/2 times 5 kilograms times 10 meters per second gives us 250 joules of energy. This ball, when it's moving, would have 250 joules of energy. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.